Welcome back. Spring Framework has evolved to become the most widely used enterprise Java development framework. I hope you already know that the Spring Framework is structured as a bunch of independent projects. A simple search for Kafka support in the Spring documentation will show you several references, and that often causes some confusion for a beginner. This video will give you a high-level overview of Kafka support in Spring and try to help you understand how Kafka support is structured in the Spring Framework. So, let's begin. I hope you already know Kafka offers two types of APIs: Kafka Client APIs and Kafka Streams API. Initial versions of Apache Kafka offered client APIs. These APIs allowed us to create Kafka producer and consumer applications. However, later they also offered Kafka Streams API to support stream processing requirements. Similarly, Spring implemented Kafka in two ways: Spring for Apache Kafka and Spring Cloud. Spring started implementing Kafka support in Spring Framework under the project name Spring for Apache Kafka. That one became a top-level Spring project to implement all the core features of Kafka Client APIs. Let me show you the documentation. Here it is. You can use this framework to create Kafka producer and consumer microservices. This framework makes Kafka a first-class citizen in the Spring Boot project, and it is aligned with the Kafka Client APIs. Great. So we covered the first level Kafka support in the Spring Framework. Now let's come to the second one. Spring realized the requirement for a specialized stream processing framework, and the Spring Cloud Streams project was born under the Spring Cloud framework. So the Spring Cloud is the top level project. Here it is. This project offers you to develop and deploy distributed applications in the cloud environment. If you get inside the Spring Cloud framework, you will see a bunch of sub-projects. Spring Cloud Stream is one of the sub-projects inside the Spring Cloud project. Let me show you. So, Spring Cloud Stream implements many technologies such as Kafka, RabbitMQ, and many more. We are interested in Kafka, but you will see two Kafka binders here. The first one is the traditional implementation, and the second one is the most recent implementation. Let me explain it. Spring Cloud Stream started to support Kafka using the Kafka binder. The initial Kafka binders were based on the Kafka Consumer Producer APIs, and they do not support Kafka Streams API. Meanwhile, Kafka Streams API matured, and the developer community wanted to use the KStream and Ktable features of Kafka Streams API. Hence, Spring started implementing Kafka Streams binder. The Kafka Streams binder is the most advanced Kafka binder API, and this course is primarily focused on the same. So the point is straight. We do not recommend or use traditional Kafka binder because it lacks the KStream and Ktable features of Kafka Streams. So we are left with the two options to work with Kafka: Spring for Apache Kafka and Kafka Streams binder for Spring Cloud Streams. Now the next question is this: which one to use? Well, the answer is simple: both. A typical Kafka project will use both methods. Let me explain. Kafka Streams is a specialized framework to implement a stream processor pattern. In this pattern, you will read a data stream from Kafka, process it, and write it back to Kafka. I'll elaborate more on this as we progress with the course. However, it is essential to understand two limitations. Kafka Stream microservices will consume data from a Kafka topic only. They do not support reading data from another source, and that's a limitation. Let's assume the following scenario. You have a requirement to receive data over a RESTful service or pull data calling a SOAP API. Once data is received, you want to do some processing and then send it to a Kafka topic. You cannot do it using the Kafka Streams. Why? Because Kafka Stream processing starts reading data from a Kafka topic. If data is not in Kafka topic, you cannot implement Kafka Streams. Similarly, if you are reading data from Kafka topic and want to pass it to another RESTful service or to a SOAP service or save it to a database, you cannot do it using the Kafka Streams. You will be using the Kafka Spring project to implement consumer API, and then you will call a RESTful service to send the data or save it to a database. So we use the Spring for Kafka project in following scenarios. You need a producer only or consumer only and also want to interact with other non-Kafka services. You are most likely to use the Kafka Producer Consumer API. On the other side, you will be using Kafka Streams in the following scenario. You have the requirement to read a data stream from Kafka. Implement some stream processing techniques such as aggregating, summarizing, windowing, and send the summarized results to another Kafka topic. You are most likely to use the Kafka Streams. Kafka Streams does not limit you on the output side. You can send the results to Kafka topic, or you can also send it to some other third-party system such as database or a RESTful service. But you are most likely to send it to a Kafka topic to implement a simplified architecture. I'll cover more details as we progress with the course. But Kafka Streams is much more potent for computing real-time aggregates and summaries. This course is primarily focused on Kafka Streams using Spring Cloud Stream. However, I'll be covering some necessary details of the Spring for Kafka project and help you understand Kafka Producer and Consumer as and when required for the examples and exercises. However, the main focus of this course is on Kafka Streams. If you are interested, I have a separate course to dive into the Spring for Kafka project and implement Kafka Producer and Consumer microservices. Great, that's all for this video. See you again. Keep learning and keep growing.